All right, we have a very interesting talk right here, which is the Intel Edison overview, and it will be given by Ajay Mungara, who's a senior product manager for software services for Intel. Ajay, welcome.
All right. Thank you. Thank you, everybody. One of the questions that most people ask me is, oh, you're from Intel and you're talking about software. What's the deal here, right? I mean, software and services and Intel, because most people know Intel as a processor company. They don't know about like it being a software company. We are, if you really look at the software and the amount of work that we do in the software space, it's like very, very significant. In fact, Intel calls out to be one of the top contributors on a regular basis on the Linux community. And we have a lot of developers working on contributing to the graphics, the Bluetooth, the kernel, and all of this work is, Intel has a very significant contribution to all of that. And also, you must have heard of companies like Wind River, which does the VxWorks, which is an Intel company. And I've worked very closely with the Wind River on a lot of things. And McAfee is also an Intel company. So we do a lot of security products in that space. And we do have a lot of software work that really happens. And when I was looking through the panel discussions, it's of course like, it's not like we are sending stuff to lunar missions or anything, but we do have a lot of mission critical software that we do write. And many of the challenges that you guys face, we do face it as well. The challenges are a little different, but I don't know why this is.
You can keep speaking.
Oh, okay. So want to talk about the Internet of Things, or what we call as intelligence everywhere. Okay. So what we are noticing over the past 10 years is the cost of sensors, right? The cost of sensors is going down, and it's expected to go down even further. So what do you mean by a sensor, right? Like sensor is anything that you can sense in the world, like sensors, actuators, temperature sensors, moisture sensors, dust sensors, carbon monoxide monitors. So all of this is really becoming extremely cheap and available. And the cost of bandwidth has gone down by 40x in the past 10 years, and it's continuing to go down. And the other part is the cost of processing data, which has gone down 60x. Because what is the Internet of Things is the I of what we call as IoT is the Internet, which really means that you're taking the data to the cloud, and you're doing some kind of processing within the cloud, which is what will make whatever you're building going to make it more intelligent, right? So the data processing power is so critical that once you take the data out there into the cloud, you'll be able to do some amazing things with it. It's very interesting, right? After I launched this Intel Edison product and the software stack, we have done a lot of events worldwide where I've had like students to makers to pro makers come in and build like products. I gave the Edison boards and say, okay, we do hackathons, right? Within 2 days, what can you actually build? And the kind of things that people have come up with, I was like amazed. People have built weather balloons in 2 days, where it goes up to, they just send it up to the stratosphere and they were able to capture the weather data. People, in fact, a couple of students, actually, when I was in China, they actually built a very interesting product. What they did was they took a combination lock and they put an Edison with a bunch of sensors, and it would run a motor and it would break the lock. I don't know why would anybody want to buy that, but people that built it, right? And I have seen people build some real medical devices where it's like heart rate monitors. People have built like musical instruments. People have built systems for the blind where you can, with gesture recognition, it can give you different stuff, right? You can do this and it'll do something for you, and you just kind of with the musical notes, you can actually get like news data and all of that. So people have been able to do some amazing things with what we have as a product, right? And why they've been, I don't know why this is gone, but anyway, I'll continue to talk. So what we built is an Intel Edison development platform, right? What it is like it is a processor combined with Wi-Fi and Bluetooth and everything with an onboard Linux, which is the size of a postage stamp. right? It's a very, very small thing where you can put it in any kind of a what we call Internet of Things solution, and you'll be able to do it. And in fact, our goal, in fact, our CEO announced earlier this year, is to take it to the size of a shirt button. And that is what the processor it will have. And in fact, if you look at it, the amount of power that this processor has is amazing. You can do a lot of things at the edge. You'll be able to do a lot of things at the gateway. You'll be able to do a lot of amazing things. So our goal really was to lower the barriers for a range of inventors, entrepreneurs, and consumer product designers to be able to quickly prototype and produce an IoT and a computing product, right? And why is it really important for you guys is because, there was a time when we used to say, oh, if you have to do this, you have to be a rocket scientist. And I'm in a room full of them, right? But there is that kind of knowledge, that kind of an ability for you to be able to do it has moved from there to people are able to do it very quickly and very smart things. They're able to do it at home. They're able to do it in labs. They're able to do it in different things. So the combination of allowing software innovation that can act on a hardware in a very, very quick prototype is the goal of this product. So you can invent. We have like what we call as an Instructables website, which I'll talk about it. People have built like amazing things, and they're able to do it in 2 days, 3 days, right? And it is you just build a prototype, see what the feasibility of it is, buy a bunch of cheap sensors, you build it, and then once you have a real product, then you can figure out how you're going to productize it. For which what we do is we have built an entire software stack and a hardware, whatever is required to make this happen. So our target audience is, we have it for maker, pro maker, and entrepreneurs, consumer IoT, where we have retail companies building smart shopping carts and a lot of different use cases, right? And then we also have light industrial IoT type of applications. We also have an industrial IoT solution stack as well, which like once you are able to build like a quick prototype, then you can actually migrate your solution into more of an industrial strength products, including VxWorks and things like that, right? So what we want to do is like you use standard stack that you have, like various runtimes, IDEs. I'll talk about that when we talk about software in detail. And then quickly move to a professional solution. Once you feel like, okay, you have all the elements that you need and you know that the solution works, then you can move to a more professional grade solution. So we do have the hardware, which is the additional Edison module plus the derivatives, and we call as expansion boards. We're asking the industry to innovate, right? So if you look at any of the standard laptops, right, Intel Inside, whenever I see this sticker, I get excited because that's a program I was a product manager for many, many years ago, where we drove that whole program. And whenever I see the sticker, I get excited. Oh, it's good. As part of that innovation, right, when we came up with. But we don't really make the laptops, right? I mean, it's like the industry kind of makes it. So our goal was, even with Edison, we provide the basic ingredients, the software stack. And that's why I'm a big fan of open source. We have all of the stack. Most of the stack that we have here is all based on open source capabilities. We have Yocto. For those of you who are not familiar with Yocto, what it is Intel recognized, a lot of the industry guys came to us and said, hey, look, if you want to customize a Linux in a very small way, it's very, very difficult. You need like extraordinary skills, and you need to worry about all the dependencies, and it's very difficult to do. People said, hey, look, if you want to build like a Linux, that I don't want all the unwanted crap. I mean, that's what they use, the exact words, right? I don't want any of this stuff. I just want, like, I know this is what I need, and I want a very small weight, lightweight Linux. So that way I can test it, right? For the test cases and what they're able to do it is very, very, very focused. So we came up with this project, which is an industry project, of course. It's called Yocto, where we are in the process of building a lot of different tools that enables you to pick up the modules that you need, and it will take care of all the dependencies, and you can build a lightweight Linux very easily. And that is what we base this software stack on. It's all open source, so you can just go to the Yocto project and you'll be able to see how you can actually build Linux. Many of the companies have come to us and said, hey man, this Yocto thing is, of course it has its downside because people who are familiar with Debian and other distributions, they feel like, oh, it's missing this part or it's missing that part, but once they get used to Yocto and once they see what you can do with it, people love it. So anyway, so the thing is, we also wanted to make it compatible with the Arduino thing. So we have this Intel Edison kit for Arduino, which is what we are raffling off today and things like that. So the Arduino is again an open source hardware plus software community where you'll be able to quickly build prototypes. So we wanted to have a board which is completely Arduino compatible and which has the processor includes the Wi-Fi and Bluetooth. So you really don't need those special modules or shields to sit on top of the Arduino board to do basic things. So it supports that. We're also having these breakout boards which we did one of the breakout boards, but we are working with many companies like SparkFun and other guys. They're building their own breakout boards, which is like every day I see a new breakout board coming in, and that's what the innovation is. When you create whatever is the basic ingredients and let the industry innovate, and you'll see amazing things. So I'll go quickly on some of these slides because, again, as I said, right, if you look at a postage stamp and Edison, that's how it's relatively very small. And our goal is to bring it to a shirt button, right? And we will do it. So it's got all the mechanical layout. I'll not go into the details of all these processes. All these slides are available to you. And you can see that it's got the high-speed USB transceiver. It's got the memory modules. It's got the Bluetooth module. It's actually a 10-layer board. So we have built everything in a size of a postage stamp, right? It's got the built-in Wi-Fi, the Bluetooth, and it's also got a pin layout, and it's got power management capabilities, onboard Linux. And the interesting thing is it's got two processors in it. One is it's got the Atom core, which is where you run the Linux on, and it also has got a Quark. That's an MCU, which allows you to run any kind of a real-time OS capabilities on it. And we are also building capabilities that allows you to build things at the MCU level, embedded programming, and then you are able to trigger alerts into the core Linux and things like that. So it's very powerful, and it can do a lot of embedded stuff, and it can do a lot of Linux stuff as well. And it's your choice on what you want to do with it. And that's the interesting part, right? When I built software all my life, and when you have a focused mission of what you want to do, it's easier, I feel, many times to build software. But what the challenge is in this is I don't know what the use case is, what people are going to use it for. So we're going to build the core ingredients that will enable the ecosystem to build all kinds of stuff. So that's a further challenge, and we work with the industry, and I would love to hear the use cases. I've worked very closely with a lot of folks to understand what type of use cases people are going to use this, and we derive our product requirements based on those use cases. So this is like the high-level product spec, if you will. And it's got it's got the RTOS here, and we have the MCU SDK and the IDE that you can actually build. It's also got the Yocto Linux version that we have. It has the Arduino IDE. It can support C++ programming, Python. It's got the Node.js, HTML5. Because a lot of times what we see is, right, when I first started working on this about a year and a half ago, before that I was working on cars and stuff. First thing I was really got excited was it was like within like 15 minutes I was able to push a button and light an LED. I got very excited. Then I realized, oh, it's been like over 100 years that Thomas Alva Edison was able to do this. There's nothing exciting about that, right? But when I moved that button to my phone, it was more exciting, right? I could use my phone to turn the light on and off. And then, so a lot of use cases that you see are people able to do the things using the cloud. So they're able to monitor their homes on their PC. They're able to control different things from your phone. So all of those things are very much possible. That's the reason why we also support the Node.js and HTML5 type of a programming interface that allows you to control a lot of things, right? You're able to make your devices do wonderful things using your phone. So that's what makes it quite exciting and interesting. I talked briefly about these expansion boards. I'll not go into the details. We talked about the Arduino stuff, the pin layout, and what you can do with this. So these are all the expansion boards. We'll talk a little bit about the software, right? So this is flight software, so we'll talk about the software. So from a software perspective, I mentioned at the core of the layer, we have the Octo Linux system, and we built like a whole bunch of middleware libraries that sit on top of the OS. And the middleware libraries are two parts, right? What we did was, there's all these different things, right? You can do with the board. You can do GPIO, you can do PWM, you can do SPI, which is like interrupts that you can run on it. And you can have like a UART, which is a serial communication. A lot of things you can do to the board, right? And you can connect a whole range of sensors to read data from the sensors or write data back and things like that, right? So if you're able to do all of those things, you need like a middleware layer, which we built, which is all open source, which is all on Git. Anybody can use any of the code that's out there. What we did was we built these high-level libraries that enables folks to connect to the various boards, right? We have different versions. We have a Galileo board, which is also there in the market today, which actually runs VxWorks, by the way. And the Edison, which we are working on supporting VxWorks and Wind River, I'm working very closely with them to get that support in. So these high-level libraries allows you to talk to the low-level I/O controls and GPIOs and interrupts and all of that. And that was not enough, right? When we started talking to the industry of how they plan to use this board, we realized that like thousands of sensors out there. Name it, right? There is a sensor for it. People wanted to build like these libraries that support these sensors, right? So instead of you having to directly talk to a particular pin and read the data and then you having to convert them, it's better that we provide some high-level libraries that allows you to control a servo, for example, or move a robotic hand or something else. So all of those APIs we built, and we built like a whole stack of sensor libraries for C++ and for JavaScript, so you can pretty much use these sensor libraries to build your own type of logic. And that's why it becomes such a powerful prototyping tool, because it's relatively very cheap. You can build like a shield, you can buy all these sensors, you're able to take all this data, and we also provide you with a cloud platform where you can take and push all this data to the cloud and do some kind of analytics on it, and then trigger alerts back into your system. So the temperature goes beyond a certain range, you want to trigger an alarm, for example. You could do all of that very, very easily. That's what our goal was. And again, we support various programming environments that includes C, C++, embedded programming. We also have Node.js. And we also have capabilities for visual programming based on something closer to Scratch. If you're familiar with it, you can drag and drop these bunch of sensors and quickly build a prototype to see how it all kind of comes together. There is an entire, well, this is not working, but we'll still go through it. So there is Arduino development, there is JavaScript development, embedded programming that you can actually do with Eclipse and stuff. There's visual programming, and we also have MCU development. So that's one of the challenges that I have. My team is spread worldwide. I have a large team of software engineers, and we have to support all of these different choices because I don't know how people are going to use the board, right? I've seen people build smart helmets. I mean, there's one guy who's, one lady actually, her husband has a notorious habit of riding a bike without a helmet. And she built this project where the bike won't start unless that guy wears a helmet. And literally it won't start. She rigged the system and she said, like, you know, you can only ride the bike if you do this. It's, as I said, right, people have these very, very practical solutions that they're building, right? Like, you know, there is this person that I met who had this elderly parents, and They were in a nursing home, and the complaint was there was a lot of light and sound pollution in the night, and that's why they couldn't sleep. So they built they used the Edison product to kind of use a bunch of sensors to track whether there was really a light pollution and things. And when they went and talked to the nursing home owners, they said, no, perfect. I mean, we have lights all off at 10 o'clock, no sound, nothing, right? And then she had a big report she came out with us and said, look, I just put this small device next to my father's table, and here is the data. Like between 2 and 4 every night, there is like big stuff going on. I don't know what. Here is the light. So the thing is, practically people are able to use some of these solutions and quickly build solutions like that. I get really excited when I hear about how people are being able to use the solution and the hardware and the software stack that we have built. And again, right, I want you guys to try it out, and if you have some real use cases using Edison and you have the software that you want to port, we can help you, right? And I want to hear like how you're using these products and what kind of innovations you're able to build on top of this. So there was this architecture stack, which is a complete software stack, which includes the trusted boot to the firmware, to the OS loader, to the Linux stack. So we do have this entire software stack, which you can follow the slides offline. It was an interesting architectural picture. So isn't it like, it's beautiful for when the final architecture actually looks as simple as that, right? Because that's a goal, right? When the end users, all of the internal complexity is completely shielded. When people talk about, hey, Google search is the simplest user interface you can, but once you click the go button, the search button, what happens behind the scenes is the most complex thing that actually happens. So that's really what our goal is, to shield all of that complexity of the hardware and the software. What do I need to do? Close it?
Close it and open it.
Okay.
Oh, maybe. No.
All right. Guys don't have the privilege of seeing all this layered architecture, because all day I've been seeing presentations with all these cool layered architectures, and I thought I also have an architecture slide. Well, no, I'm actually in the software side. I do work with the hardware people. We have a lot of hardware dependencies. We have large teams, right? We have like some of our software teams are like 100+ people in most cases, and they're spread worldwide, right? I have people in China, and in Russia, in Germany, in France, and a lot of sites even in the US. So we try to coordinate these complex projects. And there is a reason why somebody said they had a gray hair and I have no hair. And there is a, oh, there it is, my architecture picture. So anyway, so these are all the different software tools and stack that we kind of own and build. And most of it, as you can see, are GPL license, and they're also MIT licenses that we use. I also have to deal a lot with the lawyers, because every time we kind of put the code in the open source community and things like that, we have to deal with these licenses and things like that. So some of the many challenges that you guys have, I have it in a different way. So this is the architecture. As you can see, it's layered. Yeah. Layering doesn't quite work here, but
happily, the presentation is recorded.
So we have the software that currently exists, and we are actually having we're building connectivity framework enhancements with Bluetooth support, because the BLE is becoming like a huge thing, the low energy Bluetooth, and a lot of people want to use this Edison because people are building smart shirts, smart underwears, I don't know, whatever, right? I mean, literally, they came up with use cases where they built these things, and I said, okay. And they want lightweight Bluetooth to be able to communicate to your phones and to your tablets and to your PCs, whatnot. So we are trying to build all those. And we have the cloud is huge. I mean, like what you can do within your software is one thing, but what you're able to take the data from the cloud and able to build intelligent things is another, right? I've had companies where it's asking me to focus. Um, so, so what it is let's say that you have a little lawn in your house and you want to only water the plants when the soil is requires it, or the type of the grass that you have will dictate how much of water it needs. But how cool it is if you're able to take that same thing, connect to the weather API, and you know that it's going to rain, and of course once in 3 years in California. And if it does rain, you don't have to water your plant. So taking the data intelligence from not just your own system or your own sensors, but able to collectively being able to do those things is amazing. I have farmers in Africa who are using this system. They're building solutions where it will only fertilize the plant when they see pests coming in 300 kilometers from their plantation. So they don't need to fertilize their plants if they don't see the pests. So you have more organic food out there, right? So you're taking the collective intelligence of the systems. And today there is a lot of human to a machine connection. There is a human or human to human or human to a machine or machine to human, that type of interactions. But in future, the way we see it, it's a machine to machine, right? I mean, these devices are talking. A simple thing is I wake up in the morning, I hit the alarm, and my coffee pot starts. And if it knows that I have in my calendar a flight that's going to take off at 9 and the flight is delayed, it lets me sleep for 15 more minutes. How cool is that, right? And if it knows that there is a traffic accident to the airport, then it wakes me up 15 minutes earlier and says that, hey, look, you better get into the shower because there's an accident and you need to rush. So, I mean, these kind of things is all possible today. And this kind of technology exists today. And what we built is the hardware and the software solution stack that enables you to do these kind of things. And it's not about, again, right, it's not about one device, it's not about one system, it's about the collective intelligence that exists on the cloud, on the internet, and you'll be able to take it, harness it into your little device and make it a lot more intelligent. That's what this is all about, and I really hope that many of you guys, when you're thinking of prototypes, when you're thinking about building complex software, you'll think about Intel and Intel processors to help you make better software, better devices. That's it. Thank you.
You
Question?
are resilient.
Timing was perfect, huh?
No. You were resilient to fault management. Let me get a microphone. Hold on,
Yeah.
hold on. No. They actually record the voice. And we post it.
So your,
Yeah.
your platform is for the prototyping, right?
So what?
Well, to begin with, right?
So then, what type of prototype is not suitable for your platform? Is there any?
So we have some use cases which is some industrial solutions which have asked for a much more resilient products and it's a software stack, right? But these things, we have positioned it from a prototype perspective, and there are people who are using it much, much beyond prototype. Our goal is to see commercial products out of this. Our goal is to see a lot of people using it in many different ways. But when we look at supporting Arduino and making all of those things happen, it will make things happen quickly. But see, the prototyping, you can do it in 3 days, right? Or 4 days or whatever. But once you want to take that and really productize it, and if you want to be able to, it's a huge thing, right? It's an 80-20 rule. You have something working, but to take it to a real product, there is many steps that you have to take. And we are helping folks through those steps for building smart shirts and building like smart watches and all the other things, smart helmets, name it, right? People are actually building it.
But mostly real-time applications, right?
Real-time and non-real-time as well. So people are using it as a gateway product where a lot of different sensors send the data to this central unit, and it will send the data back to the cloud. It will process the information, send it back, trigger the alert, and you're able to take decisions based on that. Simple things, right? I mean, there is one company that was like, so suppose like today, right? There's a fire here, right? And if there is a fire department comes in, and if they need to know how many people were actually in the building, so if everybody are safely out of the building, it's difficult to know that, right? Because you don't know where people are, what they're doing, everything. So you can build sensors, you can take count of people, you know where people are, so that like in terms of emergency management, you're able to make better decisions. So all of these data, you don't need it unless there is a fire, unless there is an emergency. So it's necessarily not real time, but this data is there, it's out there, it's collecting all this information, and when need be, you can actually make it available, right? And there is actually a team that's building this. If there is a fire here, right, I don't know where the nearest fire extinguisher is. So if there is a fire, then all the fire extinguishers talk to each other and they kind of tell that, okay, I'm here, and they tell me, they can direct me to the nearest fire extinguisher. So the fire extinguisher has not changed for decades, right? It's not intelligent. Unless I break the glass, take it out and use it. But if it is telling me to use it and it tells me where it is, and I just open my phone and it texts me that, okay, it's giving me the directions where I can go to find it, it's amazing. And those things are possible, and people are building, using these processors, they're building solutions like that.
Has any radiation effects testing been done on the processor and the board?
What are you thinking? Yeah, it's a space application. Yeah.
So I have a tough question. Is there any indication that Intel is moving toward embedded processor design? Because all this like Quark is already going into this direction. However, from the embedded perspective, requirements are pretty different because your product life cycle is around 2 to 3 years, right? So this is how long it is in the market, and typically embedded products are in the market for 10 years.
Right.
So is there any indication that you are moving quickly into embedded domain? You want to?
So we have been in the embedded domain for a long time. A lot of people don't know about it, right?
I know 20 years ago you were, but you moved to higher margin business then.
No, we are still there because, as I said, right, before this job, I was working with various car manufacturers, and we have a large embedded business in the cars. And cars live for a long time. And when I first got into this car business, right, they said, hey, I was like, oh, why are you talking about like 4-year software life cycle, right? For me, that was alien at that time. And they said, well, if there is a bug, it's not a bug, it's a recall. So we have been in the embedded space, to answer your question, and we are making a bigger emphasis right now in the embedded space now. And we want to really support and get more into this embedded thing, both on the industrial side, variable side, and the maker community.
So, and this is kind of real direction, strategic direction
Correct.
of the company.
Yes, it is a strategic direction.
Okay, and how do you see the competition with ARM ecosystem? Because you have Intel ecosystem, which is strongest semiconductor company, and then there's ARM. These guys are definitely focused on mobile and embedded. You are focused on probably embedded, but mostly on server and desktop ecosystem. Yeah,
I can't talk from a competitive perspective, but I can definitely say that we do have a very strong focus on the embedded side. We also have a strong focus on the mobile side. You can see, like in a lot of tablets out there are having Intel inside, and the Edison and Galileo products are a testament to it. We are, if you look at like what we are doing to support not only just the hardware products, but the entire software and all of the ecosystem that's essential for you to build the embedded solutions. We are playing in every space in the hardware, right? I mean, that's one of the reasons why we went and we acquired Wind River, right? And they are in the software space for a long time, and Wind River has been an integral part of our strategy right now, and it's helping us make our IoT strategy. A lot of the Wind River products, including the Moon Island Gateway and other products, we're all supported on this platform.
I'm afraid we're out of time for
Oh, okay.
questions, so
One last?
no.
No, we are done.
Really out
Okay.
of time. So thank you.
Okay, thank you very much, guys. And yeah,
I encourage all of you with additional questions to get in touch with Ajay, and he'll make himself available. Okay, our next presenter is